Merlin 3D, a new dimension in network magic. Hey everybody, my name is John Capobianco. I've put together my scene, and if you've been watching the videos, it's been an accumulation of work, iterative steps, and I've touched up some things. I've added a lighting system, which I'll cover before I start the animation. But what I'd like to do right now, for the first time, is confirm that the blender is sensitive to real network changes. Meaning, let's add an interface, let's shut, no shut, add another interface, make some changes, and see if we can affect the blender. All right? That's the whole point, is to make network data. So all I've done is added a while loop. So it's going to do this 50 times, run show IP interface brief. It takes about 5 seconds per iteration, which gives us lots of time to mess around on the CLI. Now let's not look at rendered view right now, and let's take the mesh off, right? Let's just look at this without the lighting system, and then we'll come back to the lighting system. But let's just confirm that right over here, I've left a little room. Let's see if we get another interface, if we can get this to grow. So I have this at 1,000 frames. Let's make it 5,000 just so we don't run out of time. I've also added an animation where these logos are going to spin. And let's go ahead and start our container. So I have to rebuild it to pick up so Docker compose, and I'm going to build no cache. And let's just confirm the name of this container so I don't get it wrong. IP interface brief, I thought so. So we're going to rebuild that from scratch so it picks up our new for loop. And then let's bring it up and it will start running. Now let's make sure it runs through the loop once before we turn it off to make sure that it's actually running here. And I don't think we're going to have any problems there. So our loop is running. There are no changes. Again, our show IP interface brief this is the default. So our loop is running problem free. Now let's turn on our animation. And let's add an interface. So conft int, let's do, conft int loopback 100, IP address 10.10.10.100, 255.255.255.0. Now let's not no shut it, and let's see, is this going to pick up a new interface? And it will be here, I think, after loopback 0. Our loop finished the 50 times. Let's start that again. So maybe I need to make the loop 100 times or 1,000 times. I didn't think it would run out so fast. But now that that's restarted, our frames are still running here. Let's go ahead and see, is it going to pick up the new interface? There it is. Loopback 100, dynamically picked up from the config. Right? So now and it says it's healthy. So let's shut the interface, shut. Not healthy, no shut. And let's add an IP to another physical interface. Show run. Let's just pick another unused physical interface here. Conft int eth16, IP address 10.20.20.100. /24, no shut. Now are we going to pick up another physical interface? It's probably stopped. I got to remember that. Whoops. Yeah, it's stopped again. Let's start that again. I will adjust the counter, but I know that it's working because loopback 100 is here. Now let's turn on the lighting system. And what we should get, in theory, is this still running? Yeah. And is our loop running? There is eth16, and the lighting system appears with it automatically. Now, I don't know, maybe I need to rerun the Python. I'm not sure why some of these, those should be green, these should be green. So where is my Python? Let me just see if I need to rerun the Python, or how I can tell it to rerun the Python again. Let's open the Python. but we're pretty close here. And I bet you if I run this, it will change those colors. Yeah, you see? Well, that nick changed. Something failed in the script. Okay, so we're pretty close. We're pretty close. I know it works, and I think my problem is when I go over 10. I have some logic that has to deal with the number and the name of the file because it's 00, 1 through 9. And then I believe it's 0, 1 or 2 if it's 20. I have to figure that out. But we're making real good progress, and you see how it's changing and adding interfaces? All right, thanks so much. We'll see you soon. Hey, everybody. I fine-tuned the tiny little things, and I'd like to just continue. There were a couple little things, and they were related to just mistakes in the above 0, above 10 kind of thing. So let's go back to the screen here, and let's also change our cadence here. So our IP interface brief, let's make this 500 times. And then we don't have to worry about the container being stopped. So let's rebuild the container. And we're not going to start it just yet. Let's get the environment up here. So I'm in the rendered colored mode. And there it's starting to spawn. Now this, I'm going to have to make the plane longer if I'm going to add more and more interfaces, or adjust it, the x-axis, to be scaling along with this, which I might do. But for now, let's not worry about that. Let's go back to our rendered world here. And we have, the Merlin logo powered by PyATS for show IP interface brief. And you can see, if we want to look at one closely here, it is, let me put it up side by side, right? This is the new version of the command, right? A three-dimensional with a physical nick representing the interface. Tells us it's not healthy. This is what it used to look like, right? Show, show IP in brief. That. I mean, what would you? I don't know. I kind of like working in three-dimensional space and having it colorful and just tell me that it's not healthy. I have to look at, and then this is just, what if every interface had an IP? What if I had 100 VLAN? Like this is going to scale and get big. And now we can just from a glance, right? Okay, those interfaces are healthy over here. Just, right? Those are not healthy. Those are healthy. So let's turn the animation back on and just take a look at this from all the way out here for now. And all right, let's turn everything on. Let's start our job here, and let's get onto the CLI, and let's start our animation. So there's the spinning logos. And now let's just shut this one, so it's already down. See how it's red down here? Let's go ahead and bring it up and make it green. Let me maximize the screen a little bit more. And let's go ahead and make that green. Right? So comp t in eth16 no shut. And the animation's running, and in theory, the text, then this should go green as soon as it picks it up. Is it running? That's running. Or is it because it's... it's still down because there's nothing actually attached to it. Okay, so I can't affect that one. I can just make another one. So let's do, right, like let's do loopback then. I don't know that I can, can I shut down a loopback? Yeah, I think so. Loop 100, shut. There. Now, right, the container's running, and our loopback 100 should turn red here. Okay, it's not healthy, but I don't know why the Python, see that, the color didn't change. So there's a bit of a bug there that it didn't change over. Is that, what if I rerun the Python? Yeah, you see. So I don't know what that is, what the trigger on the Python is there. But I'm going to need to figure that out. That's okay, though. And what was the hotkey here? There's a hotkey to reset my camera. I can't zoom in anymore. But that's okay. So now let's get rid of those interfaces. And so no let's get rid of int loop 100. No int loop 100. And let's go into eth16 and say no IP address. And in theory, those interfaces should just disappear, and they're gone. We're back to the original config. And I could add another VLAN interface. It's all working as intended right now. That is just really great. So again, we've gone from this, show IP interface brief, this CLI output, to JavaScript object notation, into Blender, into a full 3D representation, a living, breathing world. Pretty incredible stuff. So, I have some next steps, and I'm going to see if I can work out on how to turn this into a web page, possibly. And then we'll go from there. I hope you're enjoying the series on Blender and Merlin 3D. Again, you can get all of this code yourself on github.com/automateyournetwork/Merlin3D. Thank you. Merlin 3D. A new dimension in network magic. Adding indicator lights. Hey everybody, my name is John Capobianco. In a different world, when I used to work in the factory, we used to call these things idiot lights. And that's no offense, and I'm not trying to offend anybody, but red light meant bad news, and green lights meant good news. And let's apply this to our 3D world of interfaces where, sure, all the information's great. We can even have it say, this interface is healthy. We're doing that. We can have a little symbol of an interface that turns red or green. But let's make a sphere, like an indicator light. And what we're going to do is make it glow red or green, depending on the state of the network, using some of the techniques that we've learned over the past few days with Blender. So we're going to have to make a little room. This is what it looks like right now. And I think right above the interface, right up here, let's put a sphere, a 3D sphere that's red or green. So let's slide everything up a little bit on the, looks like it's going to be the Z axis. So let's push everything up. And I have to push both layers up. And that's a little bit of a hint as to what we're going to be doing with, and I need the powered by and the other powered by. So what we do is we make two objects, and then what we do is make the inner object an emission that emits the color from inside of the outer sphere. Now let's push this up to 40. Now we have lots of room for a nice big indicator. Okay, so let's add a sphere to the center. And let me just turn our grid back on here, this view. And that is in the center of the room still, the X and Y. Let me make sure that the camera, or that this is set to the center. How do I do that again? Shift S, cursor to world origin. There we go. All right, so now we're going to go Shift A, and let's add a mesh, and let's add the circle. Right, that's going to make a sphere. No, I guess it's a UV sphere. Okay, so we have our sphere, and we're going to hide the sphere, and let's call it indicator. And we're going to hide it for now. Actually, let's make it big for now. Let's get it to be the size we want it. I don't know, let's say try 25. Okay, that's a little big. How about 5? Let's try 5, and now we're going to hide it, and we'll come back to if we have to resize that. So now let's go into our code, and again, we're going to have to instantiate that new sphere, and we're going to pick the indicator, And we're going to link that in here. And then we have to instantiate it in our for loop. New object list. And this is going to be indicators with an S. And then we have to connect that into our subprogram here, our invoke subprogram. All right, so now let's place those spheres. We should have, right now there's 7 of them. Now let's get them placed onto the map or onto the canvas. So we know we need a combine vector, and that's going to be the vector. And we're going to use the math node to affect that vector. What did I just, that's add. I don't want add. I just want the multiply. And now I need to bring that into the index. Let's just bring this up here so it's easy to connect. And now we need to tie the object in. So let me bring this back down and let me bring this up here for now so I can tie the object in. So let's bring the object in, and now there we go. Pretty wicked, right? And now we're going to have to put them where we want them. They're sort of there right now, and they're sort of skewed right now. So let's not rotate them at all. And let's write our scale here we said was 5. That might be a little big. Let's try 3. Yeah, 3. How about that? Now, we're going to, we want them back here. I see the y is minus 15. Those are where the lights were placed. So let's get rid of those, and then on the y-axis we want it above where that was. So the y is minus 15, it looks like. No, those are the cameras. I keep doing that. I need to find, whoops. I need to find the y-axis and the z-axis of one of these up here. 1 and then the height was up in the 20s. All right, so let's change that. Is that in the center? Okay, so we want this to be 1. And then the z up to, like, say 25. Too high. 20. Too high. 15. Too low. 17.5. Perfect. So now we have these spheres that now we're going to make colors for. So what we're going to do is go into our original indicator here and go under the materials, and let's give it a default material. I have one called default, and then we're going to add the down, and we're going to add the, should be up in here somewhere, up. Okay, so now what we got to do is delete our instantiated indicators, so that way we pick up the new color scheme. And what we have to do now is set the material, right? So that's pretty straightforward. What we're going to do is copy, let's say this one here, the objects, and our object, whoops, our object is not called Nick, it's called indicator with a capital I, indicator, and then we're going to set the slot material to up. So now we're going to copy this for the not healthy and change it here to down, and let's copy it one more time for our, and change that there, and one more time here. And now let's run this, and let's render that. And now we have red indicators and green indicators. Right? And let me turn off the mesh here and give you a full screen view. Now we have, and I'm going to smooth those objects as well. Let me smooth them. But we got a really good start to indicating lights. And we haven't made them glow. We're going to make them glow and we're going to smooth them out. So let's, we're all done with our Python since we know the Python works. So let's give ourselves a little room here and join those. And what we want is the indicator, and I want to show that object. I want to pick that object and shade smooth. Alright, now I think I have to regenerate my indicators. And now we can see they're nice and smooth and they refract the light and everything. Here, let's go ahead and do something else. I'm going to like to make them metallic as well. So let's get rid of those. Let's go back to our primary indicator. And, oh, I see the surfaces. So what I need to do is go to the surfaces. And for down, right, I got to change this. Okay, it's already at 5 metallic. Well, we could change different things on here or change the materials or whatnot. Alright, it's already doing that, so let's re-execute the node tree and get our balls back up, and then rerun the Python to get the colors in. And now we get, I mean, this looks pretty good, and we can save this as the Blender, alright, and then let's run it, and we have all our colors. Alright, so let's go ahead and I just want to make note here, our up and down for our textures, I don't want to say they're just, but they're colors. They're not, it's just the solid color of red. So what I've done is under the indicator, I've changed it to an emission. And I've set it to green and red for the different, right, indicators. And in the Python, I've changed it from using up and down to using the indicator up and down objects. So let's run this, and then let's take a look at what this looks like now with smooth indicators. Wow, and they're actually colorful, and they leave reflections on the wall. And they sort of affect the color scheme. So now there's no doubt whether or not an interface is healthy or not, or up or down. It's got a nice big colorful sphere, an indicator light, and so I could turn the animation on. Let's get the, is my VPN still up? Okay, my VPN is still up. Let's go ahead and run the container, and that's going to run, oh, I'm in the wrong folder here. And that's just going to run, and let's just turn the animation on. So now nothing is really going to change too much until I go ahead and SSH in and add an interface or remove some interfaces. So let's go ahead and do that. Let's log in. This is admin Cisco 123, and we do the show IP int brief. Right, there's the old way, and then below is the new way. So let's go ahead and we'll bring it down here, and let's just, well, we don't even know where they're going to end up. So VLANs would move at the front. We have loopbacks, and we have physical Ethernet ports.